once upon a time there was a millimeter. It was a unit of length, and it was real short. And people looked at the millimeter and said, millimeter, 1,000 of these I bet would be a meter. So we went from a little teeny tiny thing, 1,000 of them is about a yard. It's pretty big. And then these people had studied Latin, so they say, well, let's have 1,000 meters, and we'll call it a kilometer, a kilometer. And then 1,000th of a millimeter is called a micron. So that was all done. But what about volume? An example of volume is a gallon is a measure of volume. So they're saying, well, let's come up with a measure for volume. And they look at 10 millimeters as a centimeter. They look at a centimeter times a centimeter times a centimeter, a little square. It's about this big, and it's a little square thing. And they decide to call that a cubic centimeter. It is in fact, it is a cubic centimeter. And furthermore, they decide to call it a milliliter. Sometimes syringes are 2.5 cc's. This one doesn't have it. This one says milliliters. But a milliliter and a cubic centimeter are the same thing. So 1,000 milliliters, 1,000 cubic centimeters is equal to 1 liter. Okay, so that takes care of volume. But what about weight? Or what about mass? How heavy things are? So they say, well, we have a cubic centimeter. Let's fill that cubic centimeter with water, find out how much it weighs, and use that as our standard weight. And so that's what they did. A cubic centimeter of water, which is a milliliter of water, weighs 1 gram. I give it to you in this somewhat backward fashion to emphasize that this isn't so much an understanding as these are like definitions. The definition of a gram is the weight of a milliliter of water. Okay, there's 1,000 milliliters in a liter, so there's 1,000 grams in a liter. So a liter of water weighs a kilogram. Our thoughts here really are about standards, and I want to look at it through the eyes of parts per million. There's 1,000 milligrams in a gram and 1,000 grams in a liter. So there's 1,000 times 1,000 milligrams in a liter. 1,000 times 1,000 is 1,000,000. So there's 1,000,000 milligrams in a liter. So 1 part per million would be 1 milligram per liter. Notice how the way the system is set up, we can kind of cross our weights and our volumes here, which would seem like you can't do that, but the way the definitions are set up, you can do that. So 10 parts per million would be 10 milligrams per liter. A piece of trivia is that 10,000 parts per million is 1%. And that's all there is to it. Okay, let's move forward here. Let's think about the analytical balance. In a laboratory, the analytical balance is kind of where everything begins. You look at like the quantitations you're doing, or it kind of all starts with the analytical balance. It's very important, a very common piece of instrumentation in laboratories. Let's look at the analytical balance in some detail. The readout maybe looks like this. They say a paperclip weighs 1 gram. So we put a paperclip on the balance and we get a 0.9735. And this is in grams. The analytical balance gives us 4 significant figures. Recall, significant figures are those which are known with certainty, plus one which may be in doubt. So in this case, we have 973, and then we watch the balance and we see the 5 goes to a 4, and then the 5 goes to a 3, and then the 5 goes back to a 4, and then the 5 goes to a 2, and then the 5 goes to a 6. We're really not sure about this one. Let's say we want to make 1 liter and we want 200 parts per million. Okay, so we want to weigh out, let's use the same box. We want to weigh out 0.200 grams. Recall, the grams is in, the milligrams is in this space. And this is written out as grams. So the milligrams is in this place. So the tenths of a milligrams is, this is the tenth of a milligram guy. Okay, we want to make 1 liter of a 200 part per million standard. So we need 200 milligrams. Let's say our standard is plus or minus 2%. So it's got to be between 0.202 and 0.198. Can we do that? I think it would be a trick, but I think you probably could. My advice is if you're ever faced with a situation like this, to get your balance, put a piece of weighing paper on it, tear the weighing paper, and practice it with something that doesn't matter so much, and see if you can do it. That kind of practice on it. My guess is you probably could do that. Let's say you want to make the same 200 parts per million, but you only want to make 10 milliliters. 200 parts per million, and you want 10 milliliters total volume, like just a little, like this is a 12 milliliter syringe, so it would be about this much volume. You only want 2 milligrams. So your analytical balance, you're going to want to weigh out 0.0020. Can you do that? You can't do that. You're never going to weigh out 2 milligrams. Let's say you want to make your 10 milliliters, only you want to do it as a liquid. The material you have is benzene. Benzene is a different sort of material to deal with. It's a liquid at room temperature, and it's volatile like crazy. So as you try to put it, you try to weigh out like whatever you try to weigh it out and put it on the balance. Let's say you have a eyedropper or something. The benzene will scream off the weighing paper, and your weight will constantly be changing because the benzene is constantly evaporating. There's a trick to it, which is kind of neat, I think. Benzene has the density is 0.876 grams per cubic centimeter. The density, it's lighter than water, notice. The density is 0.876 grams per cubic centimeter. So if we want 0.002 grams, if we divide that by 0.876 grams per cubic centimeter, we'll end up with 0.00283 cubic centimeters. And of course, this is the same as 0.00283 milliliters, and this is a little bit of a jump. This is the same as 2.83 microliters. And can we measure 2.83 microliters? Oh yeah, easy. Just they have a little syringe. The syringe is calibrated, like you can get them calibrated as small as you want, but a real common syringe in a laboratory is a 10 microliter syringe. It's about the size of this, but it has a little teeny tiny barrel. Just pull up 2.83 microliters and add it to your benzene would typically be made up in methanol or something like that. And it's not a problem.